Okay, we continue the second part of the assembly language. Okay, so the Intel 8086 architecture. Okay, so when you use AX, okay, it means you're using a 16-bit numbers or 16 numbers. Is 16 bits number. Okay, and then if you in the hexa, okay, we can have AX equals to 1, 2, 3, 4 H. Okay, so it means they use 4 digits of hexa. Okay, so 16-bit numbers is equivalent to the 4 digit of the hexa. Okay, kalau you pakai AX. Okay, is sama same goes to the BX. So if you see when you see a BX, AX, okay, so they must be using a 16-bit or the equivalent to 4 digit of hexa. Okay, so for example, you have AX equals to 1, 2, 3, 4 H. So therefore, your the 2 digit, okay, on your left side, okay, will be belong to the AH, okay, for high byte, and then these 2 digit, okay, on the right side is belong to the AL, we call as a low byte. Okay, all right. Now we go to the classification of your register. So since your register have 14 types of register, okay, you have a 14 of register, we can categorize, okay, the register into several groups. Okay, the example, okay, they have one we call a instruction pointer or we call a program counter. Okay, so normally the instruction pointer and the or the program counter, okay, normally they are used for the register to hold the address for the next instruction that or point the next address of the instruction that need to be executed by your CPU. Okay, and then we have a general purpose register. Okay, your general purpose register, okay, they have four, yeah, uh, which is AX, okay, BX, CX, and DX. Okay, so your general purpose register basically they have two mode. One is a 16-bit mode, and another one is a 8 8-bit mode. Okay, this is for AX. Okay, itself they pakai 16-bit. Okay, okay, which is equivalent to the 4 digit of hexa. And then for the 4 digit of hexa, and then for the 8-bit mode, okay, they are divided into two, whether it's a low byte or it's a high byte. Okay, so normally the low byte is only 2 digit on your right side, and the high byte normally at the 2 digit on your left side. Okay, that is a general purpose register. Later on, during the assembly language, uh, uh, you will learn more detail about these types of register. Okay, then we have a special purpose register. Okay, so the special purpose register here, okay, they use normally the special purpose register, or they known as pointer and index register. Okay, they are so known as a pointer and also index register. Okay, they divided into four register, which is SP bukan Sungai Petani ya. SP as a stack pointer. This actually is a register that used to point the top of the stack. Okay, nanti later on you akan belajar. Okay, you akan belajar stack. So the SP ni adalah SP for the stack pointer register. Dia yang mana they will point the address of the top of your stack. Okay, and then you have a BP. BP is stand for the base pointer. So base pointer is normally they hold the address of memory that which is the beginning or the current procedures of the stack. And then you have a source index. Okay, this source index is actually the register that used to hold the address of the source in the string and also memory operation. Okay, so the source index. Normally yang ni pun dia pegang address dia pegang address for the source of the memory address, okay, for the source of the instruction. Okay, and then the I is a destination index, is normally the address of the destination for the string of the operations. Okay, so dia normally yang ni mostly they actually hold the address. Okay, and another one is a segment register. Okay, for the segment register, I used to divide a program. Okay, normally when you have a big applications, okay, uh, your program or your applications will be divided into a segment. Okay, so there are 4 segment register in the CPU, which is that used for the to locate for the program, instruction, data, and also the stack. So therefore, they have the 4 types of segment register, which is a CS is a code segment. Normally, it is used. Normally this register will hold of the segment of your code. DS is for the data segment, is normally they hold for actively used to point your punya data segments, okay, inside the memory. And ES is an extra segment, is used for if you have an additional segment for your application or program. So your this pointer are responsible to point, okay, where is the your extra segment inside your memory. And this is a stack. SS is a stack segment, bukan short sendiri. Stack segment is actually is used to point your stack statement. Okay, so bila biasanya kita punya application will be divided into module. So some of the module kita akan letak dalam stack, some module akan letak dalam extra, some module dalam, kalau data module so dia letak dalam data segment. Kalau dia code, coding saja kat situ, so therefore they have a code segment. Okay, so they were divided into segment and module lah. Okay, alright, and then we have another one is a status register, or we call as a flag. Okay, so dalam status register ni kita ada beberapa flag register. So in the flag register will indicate the status of your CPU or the result of arithmetic and logical operations. Okay, in the 8086 architecture of processor, the flag register is 16 bits wide, and but normally you have a 16 status register. Okay, tapi yang you perlu tahu adalah yang boleh kita gunakan adalah 9 bit sahaja. So there are 2 kinds of the flag. Okay, one is the status and control flag. Okay, so flag ni dia ada 2 jenis. Satu untuk status flag. Okay, satu untuk status flag. Okay, satu lagi control flag. Control flag ni nanti you akan belajar on the last at the end of the topic of assembly language instruction lah. Okay. Alright, so this is the general purpose register. There is mention about the AX. AX ni apa? AX ni accumulator register. Okay, so bila kita pakai accumulator register, okay, so even though they have nama dia pun accumulator register, so they normally is used for involve any operation for input output and most of arithmetic operation lah. Okay, we have a base register, so normally the only general purpose register we may be used for indirect addressing, so then that's why we use a base register. So even though they have a specific function, tapi dia boleh gunakan as a general functions of the register juga. So count register ni normally we to count the numbers of loop, the count number of arrays. Okay, alright, so this is what the count register is being used. And then we have a DX, which is a data register. Normally they use for the multiplication and division operations. Okay, alright, nanti kita tengok bila kita buat further on the arithmetic operations, so then you nampak penggunaan dia. So this is a 4 special purpose register atau point index register. Okay, so you have a source, okay, and this is a segment register, which is a code segment register, data segment register, extra segment register, okay, and the stack segment register. Okay, so the status register, okay, that's known as a flag, is a collection of 1-bit values which reflect the current state of the processor and the result of the recent operation. So sebelum ni in the chapter 3 dalam teori, kita diberitahu control unit akan send a signal kan, okay, control, okay, give it a signal. So signal tu dalam bentuk status register lah, okay, to tell what are the status of the CPU currently doing and what the outcome of the arithmetic logic unit punya results. Okay, alright. So out of 16 bits tu, the 9 of the bits in the A06 is being used for the 6 flag. Okay, so this is a flag that you will learn later on, okay, as you go along with the instructions. Okay, so this is a carry flag, there's a parity flag, zero flag, sign flag, overflow flag, and auxiliary flag. So each flag need will be set, okay, when they have when the will be set as a 1. So carry bila the set ni maknanya the carry flag tu equals to 1. Okay, because a certain situation lah. Okay, they have a certain situation whereby the carry flag will be set as 1 or the carry flag will be set as a 0. Same goes to other flag. Okay, right. Okay, now this is an instruction pointer, or we call as a program counter. Normally this is hold the address, okay, of the next instruction that to be executed relative to the code segment. Okay, normally dia tu akan tunjuk uh, normally dia akan tunjuk okay, you punya address next instruction. Okay, even when you compile you punya instruction itself, okay, there will be have an address for each line of your code. Okay, so therefore the stack pointer normally used for the instruction, okay, a program counter ataupun instruction pointer ni normally they hold the address for the next instruction that to be executed by your computer. Okay, so this actually hands on tu sepatutnya ada debugger, tapi debugger ni dah tak being support, okay, by the Windows anymore. Okay, so Windows 8 above dia dah tak support by debugger ni. Ni debugger command. Okay, so tapi this is example of instructions of in assembly language. Okay, later on you akan write the program, okay, macam ni. And then kalau you trace, you kena trace lah, okay, how what happened for each line of the code. Sebab assembly language ni, okay, dia are sequence based. Okay, so even as dia punya line of code tu, each of it have their own address. Okay, they have an address incremented. Okay, increment. Okay, so assembly akan check line by line. Okay, so the way they trace, dia akan trace daripada line by line of the code. Okay, so that's why kamu tengok instruction dia, code dia pendek-pendek je. Okay, so dia ada pendek-pendek je. Okay, so JMP ni macam jump. Dia jump instruction. So dia boleh jump, dia boleh pergi ke the next instruction, dia pergi ke that address. Okay, so this is nanti you akan later on akan belajar lah. Okay, as during your lab session. Okay, alright. Okay, so that's all for now. Okay, thank you so much. Okay, I'll see you on the next video.